Let's place our triangle with lengths A, B and C on the ground so that C is our base. To calculate the area, we just need to work out the height it reaches, so we can draw in this line and we'll call it Z. So Z is perpendicular to C. Now let's introduce two new values, x and y, which represent the two parts of C that fall either side of the line. From Pythagoras' theorem we have x squared plus z squared equals a squared, and y squared plus z squared equals b squared. We also know that x plus y equals c. Now the tricky thing here is to rearrange these bits of information so that we can work out z, just from knowing a, b and c. Of course, if we could find x or y, we can also easily find z, but the key is that we need to be able to find any one of them only knowing a, b and c. As it turns out, we can do this, and one way is via the value of x. First, we know that using Pythagoras' theorem, the height as determined from a and x needs to be the same as the height determined from b and y. So that gives us b squared minus y squared is the same as a squared minus x squared. And we can rearrange this so that we have the parts we'll know on the right, remember that we're assuming we already know a, b and c, and the parts that we don't know on the left. Now this is starting to look promising, because since we know x and y add together to make c, we can actually express y in terms of c, which we'll know, and x. So x plus y equals c, and y equals c minus x, and from this we have a squared minus b squared on the right will be the same as x squared minus c minus x all squared, and we can then just expand the brackets, being careful of the negative and positive signs, and this is looking better and better because now we can eliminate x squared and we're just left with negative c squared plus 2cx equals a squared minus b squared, which we'll rearrange to give 2cx equals a squared minus b squared plus c squared, and then dividing by 2c, we'll get a squared minus b squared plus c squared over 2c is equal to our x. So this means that if we know a, b and c only, we'll be able to find x straight away, and from there it's only one more step to find the value of z, and hence be able to calculate the area.